Hello, this is an example of how to solve problem 2. So what we're asked to do is to solve in Excel or by hand, and this will be the by hand demonstration. And the data were given. A track coach counted the number of minutes it took team members to run 5 laps. These are very small laps, and found 8, 6, 7, 6, 2, 6, 7, and 6 minutes. So then we're asked to figure out a number of calculations. So I'll start this problem by listing our runners, and I'm going to label them as R. So we'll start just by listing them down the page here. Here we should get our pen. As always, I do these on the Excel spreadsheet on the touch screen, but you'll likely be doing these on paper and pasting an image in. So here are the runners. R4 is runner 4, R5. And I'm going to just scroll down here. R6, R7, and R8, referring to the runners. And going across the top then, we have to write our scores, which are the number of minutes. I really need to put some time into figuring out why my pen is overacting here. Okay, and now the number of minutes we get from the problem. We have 8, 6, 7, 6. So let me draw a line going down here for the sake of clarity. 8, 6, 7, 6. I'll collapse the ribbon, give us a little more room on the screen. 8, 6, 7, 6, 2, 6, 7, 6, 2, 6, 7, and 6. And now I can draw another vertical line. So we're asked to compute mean, median, variance, and standard deviation. I'll record my data over here. So first, let's always record the number in the sample because we always need that for our calculations, and that equals 8. I can see 8 runners. Next, we calculate the mean, which is just the sum of all the values x divided by n. If I sum up all these values, I get 48. And I divide by 8. 48 divided by 8 equals 6. So we know the mean. It asks us to get the median, which I'll do up here since we don't use it for our calculations. And to get the median, I have to rank order all of these scores. And so 2, 6, 6, 6. Once I've done these. 6, 7, 7, 8. 6, 7, 7, 8. If I count over 4 and over 4, I found in the middle these 2 6s, so I know the median equals 6. Continuing on to get the variance, I know we have to get the sum of squares, the sum of square deviations, before we can find the variance. And that means the sum of all the deviations x minus m squared. And let's go ahead and get our deviations. So deviations, again, is x minus m. So 8 minus 2, 8 minus 6 equals 2. 6 minus 6 equals 0. 7 minus 7, 6 equals 1. So you'll see why I like to work in Excel, because I so often make little mistakes when I work by hand, much as I wish I didn't. 6 minus 6 equals 0. 7 minus 6 equals 1. And 6 minus 6 equals 0. Our check to see if we did our deviations correctly is to add these up. I see the positive numbers, 2 plus 1 plus 1 equals 4, plus the negative 4 equals 0. So I know that the sum of our deviations is 0. It's not a useful number, but I know I calculated them correctly. But it doesn't really tell us anything about the spread, so let's go ahead and square these deviations so we can sum them for the sum of squares. 2 squared equals 4. 0 squared equals 0. 1 squared equals 1. 0. -4 squared equals 16. 0 squared equals 0. 1 squared equals 1. And 0 squared equals 0. And so we can add these up then. 16 plus 4 is 20, plus 2 is 22. So the sum of squared equals 22 divided by, the sum of squares equals 22. Next, we go on and we get our variance, which is the sum of squares divided by n. So 22 divided by 8 equals, let's get our calculator over here. Clear it out. 22 divided by 8, and we get 2.75. So our variance is 2. Oops. See if it's writing it, 2.75. And since we squared up here in order to work through this problem, we have to take the square root in order to get the standard deviation. So the standard deviation is just the square root of the variance equals the square root of 2.75. And we can go ahead and get that right here on our calculator. So we get 1.6583 equals 1.6583. I've saved 4 decimal places here. Usually we save 4 decimal places when we might be using the number for more calculations. If we're just writing it down as the end of the problem, we can stay with 2 decimal places, but I showed 4 for now. So now we are done with problem 1. Next, it says, examine the scores to look for outliers. What score, if any, represents an outlier? What shape do you predict? So let's go down here and write B for easy grading. And as I look through these scores, I see that many of them are similar. 8, 6, 7, 6, very similar. 6, 7, 6, very similar. But 2 stands out. And so I'm going to say the outlier is 2. Predicting left skew. The tail is going to point in the direction of the outlier, I predict. And let's see what our next problem is. Plot the data on a histogram and see what the actual shape is. So let's go ahead and make a histogram. There we go. In order to do the histogram well, I have to tell the minimum. The smallest number is 2. The maximum equals 8. And I need these because these are going to go down here to create the values for the histogram. And I have to include every single number, even if there were no scores that fell along that particular number. So here are all of those numbers. And let's just go ahead and plot them. So I'll start with the 6, 7, 6. And now I'm going to reduce the screen size just a bit here so I can see the numbers and the chart at the same time. There we go. Next, we plotted the 6, 7, 6. Next, we plot the 2, the 6, the 7, the 6, and the 8. And if we look at the shape of this distribution, we can in fact see, this is probably a little bit better line, we can in fact see that we have left skew no symmetry, not normal. So now we finished with C. Let's continue on with D. It says, considering the shape and outliers, what member of central tendency would be best for representing these data? Why? Well, we know that our measures of central tendency include mean. So I'm going to write of mean, median, and mode. Let me continue. Median would be best for this distribution. It is best because the mean is strongly affected by outliers. And this distribution is skewed and has an outlier. Mode is better for nominal variables. Median is best in a skewed distribution. Okay, so we have a skewed distribution. Even though mean and median were the same, the outlier caused it in this case. And that means that median is going to be the best measure of central tendency. And that's the end of this little demo, and I hope you found it helpful.